Hello, and I'm Mitch with Acroname. A common situation that arises when doing USB testing and development is the need to have two host machines connected to one device or even multiple devices. This type of functionality can be useful for both upstream and downstream testing, where you want to externally monitor and control how devices interact with each other. There are many ways this problem can be solved using our products. However, today I'm going to show two of the most popular. The first option is our USB hub 2x4. The USB hub has two upstream ports and four downstream ports. When using the downstream ports, you will have full control of each port, including individual control of the voltage and data lines, plus many other features. The two upstream ports have three operational modes: channel 0, channel 1, and auto switch mode. The drawback with this setup is that once you pass control to another upstream port, there are only two ways to get that control back. Either host B gives control back, or you can use our embedded Reflex API to hand control back based on a time delay. Each of these situations has their own pros and cons. However, many customers don't have the ability to modify host B in order to run our Brainstem language, and timers can waste valuable time. Nevertheless, let's take a look at an example where both hosts are running Brainstem. Here we have two pieces of code that are almost exactly the same, with the exception of these lines here, which determine who to pass control back to. The first portion handles the connection to our device and ensures that it is valid. It also includes the control structure that waits for a connection when there is not one. Once we have connected, we do some basic stuff such as get serial number, enable downstream port 0, and I add a little sleep cycle here that references where you could insert your own code. To wrap up, we disable the port, pass control to the other host, and we disconnect. Then we repeat this whole process. In this setup, I will have my Mac connected to upstream port 0, and I will have a PC that I'll be remoted into connected to upstream port 1. On the downstream side, I have a serial device that will be enabling and disabling. When two upstream ports are connected, the hub defaults to port 0, so the Mac will begin with control. Here, I've configured my terminal to print the connected communication devices every second so that we can see when control is handed off. Similarly, we will be watching the device manager on Windows. Let's run this code. As I said, we will be starting on the Mac side, so let's go ahead and start there. In addition to watching the serial device appear and disappear from the control panel and the terminal windows, keep an eye on the command prompts for notification when a host has connected to a device and when it is looking for a device to connect to. You can see we have successfully passed control of the communication port back and forth between the two host computers.
The second option, and our recommended solution to this problem, is to use our MTM line, consisting of one MTM dev board, one MTM USB stem, and one MTM I/O serial board, which is basically our USB hub plus or minus a few features. In this setup, think of the MTM USB stem as a third upstream port. However, it will only be used as control. The control line will be communicating with the MTM USB stem board directly, and the MTM I/O serial board indirectly via the I2C Brainstem network. Everything else will be exactly the same as it was with the hub example. Let's take a look at the code I've written for this example. The first thing I do is find an MTM device and connect to it. Next, I want to connect to the MTM I/O serial board, which is done by using the connect through link module command. This command creates a Brainstem link to the I/O serial board through the USB stem. You will notice a small bit of commented out code here. This was used to configure the Brainstem network. Since my system is already configured, there's no need to run it again. Finally, we can enable the downstream ports and use command set upstream mode to select which host has access to the downstream ports. Let's run this code and see how the host responds. Remember that the control channel is on the Mac, host 0, along with the upstream channel 0. Upstream channel 1 is connected to the Windows machine.
Similar to the example before, you will see the communication device move back and forth between the control panel and the terminal window. However, you will notice that there is only one command prompt displaying the status of which host currently has control.
Notice that the device was successfully enumerated to each host, while host 0 maintained control the entire time. I hope these examples were helpful and that they show you just how easy it can be to deal with multiple hosts when testing and developing USB devices. If you'd like the source files for these examples, please visit our website at acroname.com and navigate to our blog. You will also be able to find a link in the description below. And remember, although these examples were shown using our Python API, this can also be done using our C++ API. Additionally, Acroname supports Windows, Mac, and Linux.